Alright, this is the third set of notes about margin of error, and so you can take a minute to read this problem. And form an opinion. Do you agree with the news reporter or do you not? They reported that, based on the results, that Alice was in the lead. So you can make a choice whether you agree or disagree, and we will look at the mathematics behind that below. But go ahead and record a yes or a no there, and maybe jot down a thought or two about why you agree or disagree. No matter what poll or survey you take, generally what we do with statistics, and I've mentioned this before, is we look at a sample of a group. We take a small sample of a group and then we make generalizations about the entire population. And so you can see that the sample, when it's chosen well, can represent the entire population. And a lot of statistics is about how well was the sample chosen, and either quantifying that, putting a number to it, or looking at it more qualitatively, like what kind of bias could be there, or what could have produced results that we were not desiring. But no matter how wisely the sample is chosen, there is always going to be some kind of margin of error in whatever calculations we do. So let's look at the above problem and look at the math behind it. If the margin of error is 3%, that means that according to the poll, 48% said that they were supporting Alice. But the margin of error means that, well, it could actually be 3% higher, or it could be 3% lower of that 48%. So she could have up to 51 people supporting her, or as little as 45% supporting her. So let's look at another example here. So if the mean of something is 48%, but we don't know the real mean of the population, so we can't look to see how closely they're related, we can increase the confidence of the mean of the population. So we can say that we're 95% confidence that the mean of the population is actually the same as the mean of the sample, or we could say that we're 90% confident, or we could say that we're 85% confident that they're the same. And that confidence level is going to be dependent on what the margin of error is. And so the smaller the margin of error, the more confident we are, and vice versa. The bigger the margin of error, the less confidence that we are. And so this range, this plus or minus range that this creates, the +3 and the -3, is called the confidence interval. If you think about it, the more things that you survey, the closer it's going to be to the mean. So let's say out of a population of 100, maybe there are 100 student athletes at some school, and you want to figure out how many of them, I don't know, drink 64 ounces of water every day. And so you maybe you only survey 10 of them. Well, your average from those 10 is not as likely to be as representative of the full 100 as if you surveyed 50 of them. If you surveyed half of them, your average would be more likely to be closer to the population that you were trying to describe. And that is in fact true. So the bigger your sample size is, the more closely it represents the population. For example, if you survey 10 students at DB about whether they plan to drive a car, and 6 of those 10 say yes, that's 60%. So how confident would you be that 60% of students at DB actually plan to drive school in the fall? So we could be confident within that certain margin of error, and we'll look at how to calculate that margin of error in a second. Let's look at a second scenario here, and so we can compare them. Now let's say we survey 100 students and 42 say yes. Would you be more confident that the results are closer to the actual percentage if you surveyed 100 as opposed to just 10? So when we surveyed 10, we got 60%. When we surveyed 100, we got 42%. Since we surveyed more people here, it's more likely that this number, 42, is closer to the actual number of students who are driving a car to school next fall. So the actual way to calculate margin of error is a very, very simple formula. Margin of error equals plus or minus 1 over the square root of n, where n is the number of people being surveyed. So that's your sample size. So if the sample size is 10, like in the first scenario, the margin of error is plus or minus 1 over root 10, which is about 0.316, is 31.6%. So your answer, the mean that you get, could be actually 31% bigger or 31% smaller than what you actually got. So it's not a very good, you're not very confident in what you got because your margin of error is quite large here. So in that first scenario where 6 out of the 10 said yes, that was 60%. If our margin of error, rather, is 31.6, well then the 60% minus 31.6 is 28.4. So it could be that only 28.4% plan to drive, or it could be that 91.6% plan to drive. And so you can see that you have such a wide interval there that your data really isn't very compelling to make any kind of generalizations or statements about. If the sample size is 100, though, if we increase that sample size 10 times, then the margin of error is going to be 1 over the square root of 100, which is 0.1. It's going to be plus or minus 0.1, which is about 10%. So the actual percentage of students, remember when we sampled 100, we got 42, right? So we had 42%. So the actual percentage of students who plan to drive to school next fall could be 10%, either more or less than the actual 42. So it could be 32% to 52%. So notice that that interval is getting smaller because my sample size is getting bigger. I'm getting more confident that the numbers are matching the actual population. Which sample size will give you a more meaningful result? The larger one. How could you reduce the margin of error even more? You could sample even more than 100 people. So more than 100 students. What would the margin of error be if you surveyed 250 students? Well, it would be 1 over the square root of 250. Which is 0.0632, so it's about 6.32%. Alright, so if the sample mean of 250 students was 45%, then the interval is going to be taking 45 and adding the 6.32, and taking 45 and subtracting the 6.32. And so we get 38.68% to 51.32%. So that interval is going to be from 38.6 to 51.3268. Alright, and the last example, if we have 512 children that were surveyed, the margin of error is 1 over the square root of 512, which is about 4.4%. So the population mean, we got 65% here. We're going to add 4.4 and get 69.4%, and we're going to subtract 4.4 and get 60.6%.